The objectives of this video are to distinguish the types of hydrocarbons, to name the hydrocarbons following the IUPAC rules, and also to recognize functional groups within a structure. The IUPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization not affiliated with any government. The IUPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. The nearly 1,200 chemists are involved in IUPAC projects. 8 standing committees oversee the union's work in chemistry. Each hydrocarbon has a specific name. These hydrocarbons and the most common are the first 10, that are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. There are more hydrocarbons, but these are the ones that we will begin with in order to explain the IUPAC rules.
Hydrocarbon is an organic compound made of nothing more than carbons and hydrogens. The two main classifications of hydrocarbons are the saturated and the unsaturated. The two differences of these classifications are between their bonds. The saturated hydrocarbons have as many hydrogen atoms as possible attached to every carbon, and the unsaturated hydrocarbons have double and or triple bonds between some of the carbon atoms. Well, now, what are alkanes? The alkanes are hydrocarbons which contain only single bonds. They are called saturated hydrocarbons because there is a hydrogen in every possible location. Now, the systematic nomenclature of the IUPAC system to name the alkanes. First, write the alkane name of the longest chain of carbon atoms. The second step is number the carbon atoms starting from the end neither a substituent. The third step and final is give the location and name of each substituent in alphabetical order as a prefix to the name of the main chain. Now we're going to take an example about the systematic nomenclature of the alkanes. In the first step, that is name the longest carbon chain that contains the double or triple bond, we're going to take the example of the hexane. There are 6 carbon atoms in the longest chain containing the triple bond. This is the hexane and the photo that is explaining the longest chain. In the second photo, we can see that the number of the main chain from the end neither the double or triple bond. The location of the triple bond is designated by the number of the first carbon in the triple bond. This is the number 3 of the hexane. Now to finish the example in the step 3, we can see give the location and name of each substituent in alphabetical order as a prefix to the alkane or alkyne name. And in this example, there are no substituents in this formula.
First of all, we find the longest chain of carbon atoms. This is 1. Then we number the atoms in the main chain, 1, 2, 3, and 4, beginning at the end near the first branch point. Here it is. Identify and number the substituents. It's already done. They are on the same branch point. Now we write the name as a single word. We begin with the substituents 2 and 2, and because they are 2 is dimethyl. And because there are 4 carbon atoms on the main chain is butane. And we're done with this exercise. First of all, we find the longest chain of carbon atoms. This is 1. Then we number the atoms in the main chain, 1, 2, 3, and 4, beginning at the end near the first branch point. This. Identify and number the substituents. It's already done. They are on the same branch point. Now we write the name as a single word. We begin with the substituents 2 and 2, because they are 2 dimethyl. and because there are 4 carbon atoms on the main chain is butane. And we're done with this exercise. To draw the structural formulas, we first read the name that we're given, which is 2-methyl-hexane. By hexane, we know that it has 6 carbons on the main chain, so we draw the 6 carbons. Then 2-methyl, so in the second carbon it can be here or here, it doesn't matter, but we will need to erase this. C3, and you're done. It's basically the same as writing the name, but to draw the structural formula is pretty simple. Here's another example. We must first find the longest chain of carbon atoms. Here it is. Now we number them, beginning at the end, of course, 1, 2, 3, 4, 5, and 6. Then we identify a number that substituents, which is only 1, and we write down the name as a one word. So one substituent on the third carbon, 3-methyl-hexane, and we are done. Alkenes. Alkenes are hydrocarbons that contain carbon-carbon double bonds. The number of hydrogen atoms in an alkene is double the number of carbon atoms. And here are the IUPAC rules. Rule number 1. Name the parent hydrocarbon by locating the longest carbon chain that contains the double bond, and name it according to the number of carbons with the suffix "in". And we have some examples. 2. Number the carbons of the parent chain so the double bond carbons have the lowest possible numbers. If the double bond is a precedent from each chain, number so the first substituent has the lowest number. Write out a full name, numbering the substituents according to their position in the chain and list them in alphabetical order. Indicate the double bond by the number of the first alkene carbon. If more than one double bond is present, indicate their position by using the number of the first carbon of each double bond and use the suffix "dn". For 2 double bonds, 3n; for 3 double bonds, tetraene; for 4 double bonds, etc. 6. Cycloalkenes are named in a similar way. Number the cycloalkenes so the double bond carbons get numbers 1 and 2, and the first substituent in the lowest possible number. Sorry about that. And another example with a cycloalkene. First, we count the edges. We have 1, 2, 3, 4, 5, and 6. So we know that it's an hexene, cyclohexene. Now that's substituents, and we have 1. So it's a methyl cyclohexene. Pretty simple, but we need to begin to count here. 1, 2, 3, 4, 5, and 6. Because if we do it all around clockwise, it is wrong, because it's going to have 6-methyl cyclohexene, and that's wrong. So we write it 3-methyl cyclohexane, and it's pretty simple. Now an example to draw the structural formula. First, we can see that it's a pent-DN. So it's going to have 5 hydrocarbons with 2 double bonds in the carbons 1 and 3. So we can see it. We have them right here. Now we have 2 and 2 dimethyl. This means that we have two substituents on the same carbon, which is the second one, and is a methyl because only one carbon. We draw it and we have something like this at the end. It's pretty simple and pretty easy.
An aromatic hydrocarbon is an unsaturated cyclic hydrocarbon with a pattern of bonding that makes it chemically stable. Benzene is the simplest aromatic hydrocarbon. Benzene is most depicted as a 6-carbon ring with alternating single and double bonds. However, measurements of bond length indicate that all 6 bonds are equal and that bonding electrons are shared equally between the 6 carbons. Two conventions for naming aromatic hydrocarbons. One is naming benzene as the parent molecule, and another one is naming benzene as a substituent group. For naming benzene as the parent molecule, you use the suffix benzene, and if there are multiple branches, number the carbon atoms of the benzene ring so that the branches have the lowest number possible. Naming aromatic hydrocarbons as benzene or like a substituent group, you use the name phenyl to indicate a benzene branch. For example, like this. 1. You have to find the longest carbon chain that includes both carbons of the triple bond. Rule number 2 is number the longest chain starting at the end closest to the triple bond. Alkaline is referred to as a terminal alkyne, and alkynes at any other position are called internal alkynes. For example, this one. After numbering the longest chain with the lowest number assigned to the alkyne, label each of the substituents at its corresponding carbon. While writing out the name of the molecule, arrange the substituents in alphabetical order. If there are more than one of the same substituent, use the prefixes D, 3, and tetra for 2, 3, and 4 substitutes respectively. These prefixes are not taken into account in alphabetical order. Another rule is that substituents containing a triple bond are called alkynyl. Another rule is that substituents containing a triple bond are called alkynyl. For example, this one. Triple bond. A molecule that contains both double and triple bonds is called alkenyne. The chain can be numbered starting with the end closest to the functional group that appears. A molecule that contains both double and triple bonds is called alkenyne. The chain can be numbered starting with the end closest to the functional group that appears first. For example, this molecule.
What are hydrocarbon derivatives? The hydrocarbon derivatives are molecular compounds of carbon and at least one other element that is not hydrogen. Organic halides are organic compounds in which one or more hydrogen atoms have been replaced by halogen atoms. The naming of organic halides is the same as the hydrocarbon derivatives. In hydrocarbon derivatives, the first step, select parent chain, the longest chain that contains the functional group. The second step, name the parent chain with suffix to reflect the functional group. Replace the ending with suffix. The third step, number parent chain. Place functional groups closest to the carbon. Number 1. Only number carbon atoms. Specify location of functional group if necessary. And at the end, add substituents if there are. Now we can see an example of the hydrocarbon derivatives. The general formula in the first one is the ROH, the hydroxyl group. The type of compound is alcohol, and the example is the ethyl alcohol. There you can see that air can be any hydrocarbon with one H missing, and air with the apostrophe can be the same air acer, or some other hydrocarbon. As you can see in the table, and as it was specified in the endpoint, it says, show a simple table where you include the main structure for the functional groups related to the hydrocarbon derivatives. Well, it's the name, prefix, suffix, and functional group with an example of each substance. We have as an example the alkane name. It has no prefix and the suffix is ane. The functional group, as you can see in the image, is C with bonds at its four sides, and the example is the propane. Another example where prefix can be the carboxylic acid. The prefix is carboxyl, the suffix is oic acid, the functional group is there, and the example is the acetic acid. In the next table, you can see the functional group, the type of compound, suffix or prefix, the example, and the systematic name. We have first the alkyne. Well, in the second line, the suffix or prefix is YNE. The example and the functional group are there, and the systematic name is the ethine. Another example is the ester in the type of compound. The suffix or prefix is STE. The example and functional group are there, and the systematic name is a methyl acetic.
Thank you for your attention. We hope you liked this video and be sure to like and subscribe for more.